What's up, guys, and welcome to the 78th Xamarin Android tutorial. So this video is going to be another quick demonstration of SignalR. So the last few videos we used to set up SignalR. We made a simple chat client that is leveraged by SignalR, and now what we're going to do is basically play around with it. Now that we have pretty much everything set up, we're just going to make another app that is leveraged off of SignalR that just sort of emphasizes really how convenient and powerful SignalR can be. And once again, this is really just kind of brushing over the surface of the API. But here we have two applications that are connected to the same server that's running the SignalR host, if you will, the server. And what they are doing is they are listening for a drag. So these are now mirroring each other, and basically all it's doing is just we're dragging obviously the view, and what it's doing is sending out to all of its clients where the view is going, and this one in a sense is mimicking what this one does. Or I can come over here and it begins to mimic what this other one does. So and these are a lot of network calls, very heavy use of the API, because every drag is calling it, you know, very many times, hundreds, thousands, since I've been doing this already, because every coordinate it's calling on touch so many times. So this is really kind of it's not clogging the API at all. As you can see, it's very fluid, it's very nice, and this really emphasizes how powerful SignalR really is. It's handling this very easily. Notice that there is a little bit, if I'm on the very edge of this, it's not the very edge of this. That's a lot about with a screen density. This is similar to like the Nexus 5 or the Galaxy S5, and this is a tablet 7-inch. So the screen density is different, and that's kind of what's throwing off this. And then if you really wanted to make something that's really going to be one-to-one mirror, you'll have to account for screen density. And since that's a little beyond the scope of what I'm trying to show here, I'm not going to go into that. But that's just in case you're wondering, that's a lot of what it is. Notice how it kind of jumps around a little bit, but the idea is that it's making all these network calls to SignalR, and really is showing how robust it is. So with that being said, let's go ahead and get this started, and I will show you guys how to implement this. So we have a new instance of Visual Studio. Let's go ahead and open up the new project wizard, Android blank app as usual, and we'll do SignalR drag. Yeah. So tutorial. I like that. All right, so the concept's going to be pretty similar to, if you guys watched the previous videos, it's going to be pretty similar to what we had going on with the chat client. Basically making a connection to the chat hub, making a function for it to call, and then giving a function on the client for the server to call, and there you go. That's pretty much the going to be the concept of it. So with that being said, let's go ahead and get started on that. Let's get rid of this template code. So I'm going to jump over to the layout, which is going to be, what's going to be super simple. All it's going to do is show that cube. So if the first thing we want to do is we want to change the parent to a frame layout. So if we do frame layout and then paste that over there. So I want the parent to be a frame layout, and I want the cube, or the square view, will be simply just a view. So it's going to be really simple. Let's go ahead and change actually that, and then these are going to be hard set. We're going to do 100 dp. It's not going to need text anymore. It will need a background color, which will be blue, and name that Draggable View. Looks like we're getting there, and then we can just change the layout gravity. Because we are in a frame layout, we can change it to just center, and we can easily have it centered inside of its parent. All right, so that's where it's going to start at least. Let's go ahead, and that's going to be it for our layout file, it's going to be pretty simple. So I'm just going to do a rebuild so the IntelliSense kicks in. And let's start programming, guys. So the first thing we want to do is we want to do a few find view by IDs, of course. So we're going to want to grab the root, the parent layout, if you will. So remember that is a frame layout. So we'll call it accordingly. And the next thing we're going to want is we're going to need a reference to the actual draggable object. So that's going to be the draggable view. And we're going to need some more, but let's just focus on those for a second. So now that we have those as class variables, we can do, of course, mroot, find view by ID, and we want to cast it to a frame layout. And the ID is actually, I didn't do that. So let's go back into our main source, and we want to change, or actually added, I'm sorry, an ID root. All right. Now the next thing we want to do is to say the same thing for the view, and we don't have to cast it because, and as a matter of fact, it's at its base class, which is a view, and by default, if you notice right here, this will actually pass back a view because it says where T is inheriting from a view. Therefore, we don't have to do anything. We could cast it to a view, but that would be redundant, and that's what it defaults to anyway. So what we could do is resource.id, and we do draggable view. All right, guys. So now that we have a reference in code to our objects, we can now do some more stuff with them, which what we're going to do is we're going to wire up a touch listener. So with that, this method that we wire up, this is going to get called every single time the object that we have is dragged. So, or touched, I'm sorry. And then we can check for a drag in the touch method and all. And we've done a little bit of this, but there's nothing explicit that we have that I've done that's, had a drag, but it is pretty straightforward. So I'll make sure that I explain it though. So what we're going to want to do here is to do a hub connection, and notice that if we do control dot, we don't get any sort of, or we get some quick actions, but nothing that we want. And that is because we have not yet brought in the SignalR component. So if you right click, get more components, you can, the easiest way right now is just to get the component from the Xamarin component store. Okay, so if we do SignalR, and let's go ahead and add to app. So it should take care of the rest of it for us. We should see that there's a ASP.NET SignalR.client DLL that we are now referencing. And now if we were to do hub connection, goes new hub connection, control dot using, we can import that now. Sounds good. And I will be using the server that I have running the SignalR ASP.NET application. It's listening on port 901. So look, I did say in the previous videos, if you have not set up anything like that before, or don't want to publish the API, don't know how, or having trouble to, for now you feel free to use this URL, and that'll give you access to the functions in the ASP.NET that I'm using, and that's it, of course. So you will be restricted to only those functions that I have written out, but they will get you started and get this example if you're following along, get it working. So that being said, let me go ahead and make another class variable. We'll call it iHubProxy, chatHubProxy, and we're going to make this a class variable because we are going to be calling it in multiple functions throughout this class. So let's go ahead and make a instantiation off of it with the hub connection, and we will create a hub proxy chat hub. And we are doing chat hub because we have a hub called chat hub inside of the ASP.NET server SignalR application. All right, so now that we have a connection to that, what we can do is we can await. We want to await, and we want to start up a connection. And I'm getting some errors because I'm using an await without an async call for the method that I'm using it await inside of. So this will just connect the to the hub connection. This will take our client and connect it to the server application asynchronously. Now, just to be on the safe side, let's go ahead and right click, and I will surround with a try catch. And of course you can do whatever you want in here. Handle errors. All right, so there we have it. And the next thing we want to do is let's actually get the dragging working. So let's come back over here before we do any SignalR stuff anymore. Let's go ahead and get the dragging working. So what we're going to do is we're going to make this sucker drag. So the first thing we want to do is we want to wire up or to start up a switch event. So switch, and we want to check the event to check the action. And what this does, guys, is it checks to see if it's down, maybe double tapped. I think there's a move action, so you can check for a whole bunch of actions. What that means is, okay, this view was touched, and what we're checking for is how was it touched, and how was it touched. Depending on how it was, we will then code accordingly to that. So we can check for motion event actions dot, and then here you go, button press, cancel, down, hover, enter, mask, outside. There's lots of different ones, but the one we're looking for, the first one, is going to be down. This is the user has touched down initially on the first time. So this is a first. This is where it's at right when the user touches their finger on this view. And what we need to do is we need to get the initial delta, so X and Y. And the way we get that is by using some variables, of course, and we're actually going to want them to be persistent throughout. We don't want them to be local to the function because we want to keep track of where that is throughout the whole application. Therefore, we want to make it a class variable. So we will make them floats, and we will do m x delta, and we will do m y delta. And we can initialize these to 0 just to be explicit, as they will initially be until here. So right when the user has touched down on the view, which in our case is our blue square, we want to keep track of where that happened. So the delta, the initial delta, is the way we get that is the sender is the view that was touched. So that is this thing right here. So the sender is that. So since using that knowledge, what we can do is we can actually let's make it a little more explicit. Touched view equals view as view. Oops. Sender view as view. Okay, so that's going to cast it up to a view, and then with that, what we can do is we can do touched view dot, and we can do get X. So this will get the, let's see if it gives us any IntelliSense on this, the visual X position of this view. So this is where it's at. This is the position of it, and we're going to minus by another variable X, which we have not yet created, which we will do up here. So what this is doing, so float X equals E dot event dot raw X, and then we'll do the same thing for Y. So this gets the raw X and Y of where you have touched down. So the user has touched somewhere on the screen, and this gets the actual touch where it was touched on the screen. And this changes, of course, every time it's touched. And then so what we're doing is saying, okay, where was the view touched at minus where the finger was, and that gives us the initial delta down. So this gives us the basically the position of the view. That way, it's kind of hard to explain that the next time that we move, when we do the move function, we will, or the move event, we will have the x coordinate, and we will need to use that because we will need to move it by how much it has moved previously, plus where our finger is at now, because we are dragging. So this is where our finger is at this instance, and then when we move, it's going to be, of course, at another instance, and we can get that difference and animate it, and that gives us that drag effect. So if it's not making sense right now, let me just kind of code away, and hopefully it'll become a little more clear once you see it in code. So we'll do the same thing for get y. So the y position of the view minus where you have touched. And then of course we need a break. And then what we'll do here is we will check for another action, and this is going to be the move. So this is going to be the one where a lot of the magic happens. And what we want to do here, let's first put a break. What we want to do here is we want to do view, or touched view, because now we're going to want to animate. We're going to want to, and there's lots of ways to do this. You could change the margin of things. You can make the view move in many different ways. But I find using the animation library, the view property animator, is pretty easy, and it's a little more straightforward, at least in my own mind. So we'll do x, which means 2. So we're going to animate it to this position, to this x position, which is going to be e.event.raw x, which is where our finger is at this very instance, minus x delta. And really what's actually the mx delta is maybe a little bit misleading. To me, the proper name, actually, let's rename that my, do that for init for initial, and we'll do that there. So this is going to be really, actually, the down is going to be the initial position of x, and then the initial position of y. And it would still work if you just had this, but what's going to happen is when you first touch down, because it's going to want to take it to where you're touching at that moment, it's going to like jump away from, when you touch it, it's going to jump away from you, and we don't really want that. So we want to give it like an initial position, which is what that's taking care of. So sorry about that, guys. I do apologize. Sort of you kind of go with things, and then when you sort of talk about it, it starts to make a little more sense in a different perspective. So hopefully that helps. So, and that's a lot of it because we're animating and we're not doing like a margin kind of drag. But I do find this way a bit easier and a little more straightforward. So set derivation is 0, so we want it to happen immediately, and then we start it. And then I don't believe that you have to actually call start explicitly, but I like to just call it just because it's there, and when you're looking back on it, it makes a little more sense. Now, the last thing we want to do is we'll just have a default case, and we can do anything right here in default, but we're not going to do anything, but you can always add some code later. And this is really important, guys. What we want to do is we want to do invalidate on the root. And what this does is it forces Android to redraw its views, and because we're doing it on the root element, the parent, we're forcing it to be redrawn, because if you don't do this, it will still work once again, but it'll look really weird. It'll kind of look like it's scaling in and out, so it's getting bigger and larger as you move it. So by forcing it to redraw itself, you get a more smooth animation or drag. Now the next thing, and really the last thing we want to do, is now the SignalR stuff. Okay, but let's go ahead and run this and make sure that we are getting to where it's actually dragging, and then we'll call out to SignalR and make sure it's doing its thing. this up. Oops. All right. So it looks like we're still getting a little bit of a jump. This is the jump I'm talking about. And not really too sure why. Let's go ahead and see if we can examine the code and get a feel of what's going on. It's X, Y. Let's get in the action. Submit. So what I'm looking over seems to be okay right there. Let me minus. Oh, that's why. So I have done a minus instead of a plus right here. So we want to actually adjust for the initial position that the user has touched at, which is initial, and I was minusing, so I was sort of exponentially moving it away from the where the user touched. So this should get us back on track. I apologize once again, but usually you know, instead of editing stuff like that, it's sometimes better just to leave it in, and that way usually when you watch someone else make a mistake, it maybe becomes more clear in your eyes. And if I help you sacrificing, you know, my own self and my own dignity by helping you in the effort helping you guys, I guess that's a win. So that seemed to be the problem though. So as you can see, we get a smooth. Notice that we don't get any kind of jump when we touch it. We get a smooth drag. So that is good. So the dragging is all good. Before I know in the example I had a different background. So just to stay consistent, let me go ahead and change that to the correct background that I had in the example. And now the SignalR stuff. Okay, so now we want to call out to SignalR, and we want to tell the client, hey, I've moved, move your object, and that way you can mirror what I'm doing. And the way we do that, of course, is by calling out to the server. And then this is this project right here. So we want to add another method in ChatHub that the user can, or I'm sorry, the client can call out to call out to all the other clients. So what we're going to do is we're going to make a method. It's going to be void, and it's going to be it's going to be called drag view, and it's going to take in 4 parameters: the raw X value, the initial X value, and it's going to take 2 more, the raw Y and the initial Y. And all it does is do clients, and then notice that we didn't up in the chat message, we did all. So we want to call out to all the clients and plus the client that called the server. In this case, we don't want to do that. We want to do every client, call out to every client except the one that made the initial call to the server, right? Because that one's already being drawn. That one's already dragging locally. It's being dragged by the user. So we don't want to have a call come back to it telling it to be dragged because it's already doing that by the user. So what we want to do is we want to do others. And that's what that method is for, this property. What it does is it calls out to every other client and not the client that called it. So if there's 10 clients, one of them called it, it's going to call all the other 9 and leave that one out. So that's perfect for this example. And then we can name this whatever we want. We'll do update view. And then we're going to pass in, of course, all of the values. X, raw Y, and Y. All right, so that's pretty much it. This is local. I'm going to go ahead and I will publish. And that published it to the server. So now it's live on the C for Beginners server. And what we can do is now come back here locally and we can call out to the server using the chat hub proxy, we'll do on, and we're gonna call it to the server. We'll do float. Or, I'm sorry, that's the wrong part. This part's actually a little easier. So what we're gonna do is we're going to make this asynchronous because we're gonna make an asynchronous call. So we'll declare async on this async. If I can spell it right, we'll declare it on this method because we will be using it, and we'll do we'll do await m chat hub proxy, and then we're gonna invoke the method that we just made on the server. So that is this thing right here, just to be sure, copy it, make sure it's the same, and we're gonna do a new object to pass in all 4 of those parameters. And it's gonna be e event, so the raw x, and then we're gonna do m init x init and e.event.raw y, and then finally m y init. Okay, so that's going to go ahead and call out to our server and call this method. Now it's going to in turn call all the other clients, and it's going to call a method called update view, which we have not yet wired up. So what we're going to do is wire that up, and that's going to be calling all the other clients to say, hey, drag your view. Another client's view just dragged, so you need to update yours. And we're going to do that, maybe we'll do it right here. So we'll do m chat hub proxy dot on, and remember this is going to take 4 parameters. So now we did that, and now it's going to be, okay, what's the name of the method that's going to be called? Update view. And then notice right here it's asking for an action where it takes 4 parameters. So we'll go ahead and make that. So we'll call it raw x, init x, raw y, init y, and let's wire that up. Okay, so now it's like, okay, well, this gets called. What do you want to do inside of here? Well, we want to actually reflect it. We want to drag. We have all these values now, raw x, init x, and so on. We want to now drag the draggable object. We want to do it programmatically. So let's go ahead and do that. Make sure you do run on UI thread. We're going to want to make sure this runs on the UI thread, and we will do something like this. Okay, that should be good. And we'll do m draggable view, and it's going to be literally the same as this right here, guys. Although we can't use this local variable touched view, but we know that this is going to be the same as this view right here, which is draggable view, because that's the one we wired up. So we can now replace it with that. And then raw x we can now replace with this, and replace it with raw y, and init y, init x. This can remain the same. So it's just basically taking these new values that were passed in through this method all the other clients. The other clients are running the same exact code, and what it's doing is it's saying, okay, hey, update your view programmatically, change it to these new coordinates, or animate it, if you will, and there you have it. Now you have a mirror or a reflection of it. So let's go ahead and install this application on both of the emulators and make sure it's working properly. Oops, actually, you know what? Before we do that, one last thing. We do want to make sure that we call Invalidate. Remember, I told you that if you don't call this, it'll still work, but it'll look weird when it's animating. It'll just leave it out and you'll see what I mean. So it's kind of hard to explain. It'll just kind of look a little squishy, I guess you can say. So with that being said, that should be pretty much all that we have to do. As you can see, guys, the same concept of it, simply just, calling out to the server, and then have all the other clients calling out and reflecting whatever you want to do in that code. So this one's not running it, let me go ahead and stop this now, and actually let's go ahead and install this on the 7-inch, run this one. And you can imagine that like this is a, this is a really simple example of what could be a game that you might play with your friends. You can make an app to where you can make a hangman app or something like that, or something that really you want to make a live connection with other clients, and they can kind of interact in different ways. And this kind of really emphasizes that. Maybe a little game, something that really both users are seeing at the same time. This really shows that this is really powerful enough to do that. So that was kind of the at least the example or the situation that I was trying to emphasize in this tutorial, is really how powerful SignalR is. And there you have it. Nothing new from what you saw earlier, but this is exactly what we wanted, and this is how to achieve it. And like I said, you can really make a simple. I think it would be cool if you were to be able to make like a simple game, but being able to have the user control one portion of it, and the user control their player, and the other side can control their player, and then you have an object or something that you kind of just interact with and play around with. That'd be the start of something really cool, and then maybe you can build onto that and see where you can go with this. But this really brings in interaction to your application or whatever you're doing. And there's just tons of things that you can do with this. The two examples that I showed you are literally just kind of the tip of the iceberg. But this one, I feel that this really shows how powerful and how easy it is to get SignalR up and running. So there you go, guys. Another example in SignalR using Xamarin. Thanks for watching.